welcome back to our part 5 of our series where we're going to address some client questions on PCO and ionization and how it can help indoor air quality. So this is a fun topic. It kind of takes me back to high school chemistry class talking about ions. So I don't remember much. This is going to be a great refresher. So Ray, I wanted to start with you and see if you can get us started here before we jump off with some client questions. So can you tell us, what does PCO stand for?
Yeah, so photocathodic oxidation. And the main principle here is that you have a source of energy, which is a UVC lamp. And on the inlet and leaving side of the energy source, you have a precious metal, in this case a titanium screen that's dipped in a ceramic. And as the energy is radiated from the UVC lamp, it creates ions. In the case of a PCO, it creates something called a hydroxyl. The hydroxyl is a positive and negative ion, and those ions are very unstable. They're half-life of about a half a second, and they want to reform in a more stable, chemical base, right? So they're looking at a molecular bond to try and restabilize themselves. And what they do is they break into other carbon chains. The other carbon chains floating through the PCO system are things like viruses, bacteria, VOCs, smoke, fossil fuels, whatever may be in the air. And it breaks them apart, tears them down. In a sense, it oxidizes them. It actually breaks them down. And it creates things like CO2 and H2O. There's other very small byproducts, unmeasurable. The interesting thing about the technology is that it really purifies and cleans the air and removes and breaks down those contaminants that are what would be considered portions of bad indoor air quality.
Can you tell us a little about the ionization system?
So an ionization system, there's several manufacturers and products that make that, but the one that comes to mind is a bipolar needlepoint ionization system. And the way those work, they create ions, positive and negative oxygen and hydrogen ions. And they do the exact same thing that a PCO does. They do it in a much longer period, and they do it over a much longer half-life. So they flood the space with the ions. They're usually either in a duct or a generator in the space or in the air handling unit. And it floods the space with those ions, and it purifies the air, cleans the surfaces, helps bind some of the larger dust particles together, so you get a better effectiveness out of things like filters. But just like PCO, ionization has concerns related to ozone. You want to make sure whatever product that you're looking at whatever technology, specific manufacturer's technology, that it meets the EPA standards and the UL label listings for the minimum ozone output. We don't want to have a product that creates another contaminant in the space, such as ozone.
So Des, can you tell us a little bit about the health concerns involved with these products?
Yeah, I guess the main concern with ionization systems is that to deliver charged ions into the space, they flood the space with them into the breathing zone, and they attach themselves to the germs, the viruses that are in the breathing zone, kill them and deactivate them. That raises a concern with us because we are carbon-based beings, and the concern is that they can potentially cause long-term health problems by us breathing in the charged ions.
Good to know. So one last question, just to really close this in before we get into the client questions. What would you say the difference or the big difference is between PCO and ionization?
So the big difference is that the ions live for half a second in a PCO, and they live for up to 3,000 seconds in an ionization system. So they flood the space, and the space is regenerating ions continuously in an ionization system so that they maintain a given concentration so that it has an effectiveness to kill viruses and bacteria.
Yeah, and the PCO systems are typically attached to the return side of the equipment, which is either in the ceiling or in a mechanical room. So it really is contained away from the occupied space.
This is great. I do feel like I'm in my chemistry classroom once again. So it's it's fun to talk about some topics that bring back good memories. So our clients had some questions that we might have already covered, but I'm going to ask them anyways. So feel free to go as long as you want to answer the question or as short if you feel that you already answered it. So the first question we were asked is, how does PCO kill viruses?
The oxidation process is what actually kills the viruses and bacteria. So the molecular structure of the molecules that it breaks apart and reestablishes are what renders them inactive.
All right. Our next question is, what kind of environments would be good for PCO? It's a good one.
Yeah, I think any environment that has indoor air quality concerns relative to things like smoke, bacteria, viruses, mold, pollen, it can be applied in a lot of different facilities in a lot of different ways. It can be applied at the air handling unit. It can be applied in a recirculated unit in the ceiling. It can be applied in a recirculated unit that sits on a floor in a critical space that has to be occupied, such as a secure room that people have to occupy to have a conversation, and there's no option to do it over the phone. So there are certain conditions where you still have to meet in a room. And these types of strategies can provide ways to improve the indoor air quality in those small enclosed spaces.
This one gets a little technical. In a PCO, when two radicals pass through the mesh, does it become ozone or reformed H2O?
Well, there is some ozone that is created at a minute level, which is contained within the unit. The ozone created is way below the limits established by the EPA.
So the interesting thing apart is the other byproducts is CO2 and H2O as it breaks apart viruses and bacteria and other carbon chains. But it's also important if you think about CO2 and H2O, they're byproducts that are normal in the air that we breathe. But the PCO doesn't create or generate enough CO2 or H2O to change the parts per million measurement in the occupied space or the percentage of relative humidity inside the occupied space. It's at a very small molecular level, and it does not affect the quantities in the workspace or breathing environment.
So not a humidifier.
It's not a humidifier.
No.
Good point. No, I think that's a great point.
Okay. So the next question is, do you need a prefilter for a PCO?
Yes, you need at least a MERV 8 filter to protect the medium in the PCO. Otherwise, the medium will become the filter. The life of the filter will or the life of the PCO will diminish rapidly.
All right, now we're going to get into some cost questions. How much does it cost to upgrade existing units with a PCO? And how much would it cost to have an ionization system?
I'll do a little bit of a comparison to allow you to understand the different technologies and how much they cost relative to each other. So I'll use the same comparison of a 100,000 square foot office building where you might have a floor-by-floor air handling unit. And that's going to be, the PCO is going to cost, the equipment itself is going to cost around $20,000 for that application. So it's close to $1 a CFM. And it could range somewhere between, 80 cents to $1.20 a CFM in addition to the cost of the equipment to install it. So you're looking at a total installed cost of around $1.80 to, $2.25, somewhere in that range to put in a PCO and a 20,000 CFM air handling unit on a typical office floor. In contrast to that, you would look at a UVGI that might be in the range of $10,000 installed, and an ionization system would be maybe just below that, somewhere around $6,000 to $8,000. So there's definitely a range, and they all do slightly different things. They all are very effective in actively killing viruses, but they do have different applications and different locations and different equipment, and for different occupied spaces. And whether it's occupied or unoccupied also would have an impact on which system you would apply.
So this is another question on cost. How much does it cost to upgrade new units with PCO during manufacturing?
So if we're talking about the unit that Ray mentioned before, like for 20,000 square foot floor, the cost of the equipment was around $20,000. Installing it in a factory, it's going to be a lot less than installing in the field. There's going to be a lot of savings, and it's going to be a cleaner installation.
Are there any concerns about PCO producing aldehyde and formaldehyde as a byproduct?
And the answer to that question is the earlier technologies that were used in the PCO were some products and some processes that actually did create some of those byproducts. The newer technologies that have been tested and cleaned up, much in a similar way that they don't create ozone, they don't create the aldehydes and the formaldehydes as a byproduct anymore.
All right. And last question, guys. What type of markets have you seen installing PCO systems?
So we've seen markets from office buildings to hospitals to casinos. There's a large variety of clients and types of clients that are applying PCOs. It is widespread now across multiple markets, and there's more and more users starting to study this technology daily.
All right. So Ray and Des, before we wrap up here, do you have any lasting comments or any things that you would want our audience to remember?
I think it's important to know that you need to study the application of PCOs and ionization as it applies to your systems in each building. One of the things as a professional engineering firm we want to make sure everybody takes away from this little topic is that we're not recommending ionization in occupied mode. So while it may have a place in an unoccupied mode to help cleanse the air and the space in after hours or out of hours times, we're not supporting the ionization process in the breathing zone when occupied.